Letter combinations of a phone number. Let's look at the problem description. Given a string containing digits from 2 to 9 inclusive, written all possible letter combinations that the number could represent. Let's look at the example. If the input is digits 23, if you look at the number 2 on the dial pad on the image, 2 has 3 options A, B, C, and 3 has D, E, F. So if the input digits are 23, the possible combinations are AD, AE, AF, BD, BE, BF, CD, CE, CF. Let's look at the example 2. If the input digits is given as an empty string, the output is an empty array. Let's look at the possible options for 3. 2 has A, B, C, and 3 has D, E, F. If the input is 23, the first letter can be A or B or C, and the second letter can be D or E or F. And let's look at the possible combinations now. AD, AE, AF, BD, BE, BF, CD, CE, CF. From this you can understand by looking at the image that this is a class of this is a problem of backtracking. And once we start at A, we look at the second digit 3 options, which is D, E, F. So once we go from A to D, and the length is 2, and the input length is also 2. So we add AD to the list of results. And we go back from D to A, and the next option for 3 is E. So AE. And once again the length is 2. So we add it back to the list of results. And we take out E from the string. So the string has A now. And we append F to the string, which becomes AF, and which length is 2. So we add AF to the list. And once we take out F from the current string, which has E, and there are no other options for the digit 3, so we take out A as well, and now go to the next option for digit 2, which is B, and add it to the string. And for B there are 3 options, D or E or F. First we add D to the string, and once its length is 2, we add it back to the list of results, which is BD. And now we eliminate D, and which has B. So we add BE and add it back to the list. And next take out E from the string, and which has B in the string now. So B is appended with F to become BF, and its length is 2 again, and we append it to the list of results and take out B. And now once all the options for B are over, we also take out B. Now the string is empty, and we add C first to the string, which becomes C. And for C there are 3 options. So first we add CD, and once the length is 2, we add it to the result, and we take out D. And once D is taken out, we add E to the list, E to the string, append and add it to the list. So similarly we add next CF, and once CF is done, add it to the list of results. F is taken out from the string, and C is also taken out from the string, and there are no more options left to iterate. So this is the entire list of results. Let's look at the solution now. For the solution, first we define an empty array list of strings to hold the results, which is list string results new array list, and it creates an empty array list of strings for string objects. The first case, if digits is null or digits length is 0, we return an empty list. So this condition makes it possible. Next, for the scenario we have, for every digit has 3 strings, 3 character options. So we create a map from character to string to hold this mapping. Okay, so 2 is mapped to ABC, 3 is mapped to DEF. Similarly, we put 2 to 9 into a map of character comma string. Next, we start with the depth first search algorithm. Initially, for the algorithm, we need this mapping number to chars, so we pass it as a parameter, and we start with index 0. Okay, and next we need to pass the input digits, and this string builder is used to hold the current combination of the string, and the results to hold the results. If you look at the DFS, so first one is number to chars map, next is the current index, next is digits, and then a string builder to hold the current combination, and then the results. So let's look at here first. So yeah, initially we started with 0 and 0 index. So if the input is 23, 0 index contains 2. So we look at what are all the characters present at 2. So to get that, we do a get and get ABC into chars initially. And for ABC, as we have looked at the tree structure, we start with A. So for every character in the characters array, which is A, B, C, we start with A first. Okay, and once we start, we have to append it to the current combination, which is currently null. So we add A to it, and once A is added to it, for A we know that there are 3 options, D, E, F. So we call the DFS algorithm with a recursive call and make the index as +1, and we pass the current combination to it. So current index has 1 input now, and current combination has A. And when this recursive call is made, the current index is 1. So current index 1 means 3. 3 has D, E, F. So for the chars array, we get D, E, F. And when we get D first, we add D to the current combination, which becomes AD. So we know that AD is one part of the result. And when we make the DFS call again, this time we call it with 2 index, and index 2 is equal to digits length, which is also 2. So we add the current combination to the results array list, which becomes AD, and we return back. And when we return back, next our intention is to append E to A, but the current combination has AD. So we delete the current character first to take out D from the current combination, which leaves with A. And as it is a loop, we append E now. And DFS call is made again with index 2, and the results array is appended with AE, and a call it returns back, and once it returns back, E is deleted again and as part of the for loop, f is appended to the string a, which becomes af. So once af is also added to the array list, for the second for loop, f is removed from the current combination, which is af, which becomes a, and when the call is made back, in a is also eliminated from the current combination. So current combination is only empty now, and for the initial for loop it was a b c. So current letter points to b, and b, it starts with b now, b d b e b f, and then c d c e c f. Thank you.